This is going to be covering Node.js 16 and a related subject that I like to call modern JavaScript. So I don't know if everybody can see that or not. A little about me. My name is David Fecky. I'm the co-organizer for the group, and I also have a blog you can get to by going to feck.io/blog. And I blog a lot about JavaScript and Node.js at that blog. I also repost on Medium, so my stuff is up on Medium as well. And I also started a YouTube channel recently called Polyglot Engineer. And that channel is geared specifically to people that are programmers, software engineers that are trying to, maybe learn a little bit something from another language or another platform, but maybe been coming from a different platform. And so that's one of the things I'm hoping to accomplish with that channel, is to provide content and stuff for that group of users. I'm also up on GitHub as well, and I also post daily on technical topics on the JaxNode Twitter account and the Polyglot Engine or the Polyglot Engineer Twitter account. So that's enough about me. I'm also looking for people to present. So just over the last year, I think just the nature of not being able to meet in person, stuff like that, I've had fewer volunteers for doing presentations for this user group. And, we typically are geared to doing JavaScript, JavaScript frameworks, Node.js type of technologies, but we also cover other things as well. So there's a lot of people that are doing or working with Node are also working with microservices. And so languages you might use with microservices or microservices in general, microservices type technology, those are all kinds of subjects and stuff that we talk about. We also talk about, cloud-based technologies, what people are using with AWS or Azure, that sort of thing. So it doesn't have to be on JavaScript. It can be on plenty of related topics. So we are always looking for speakers. So with that, let's go ahead and get started and talk a little bit about tonight's subject, which is Node version 16. So the way that the Node Foundation kind of like does these releases is they always have 2 concurrent releases at the same time. They also support older releases as well. So they have what they call the LTS, or the long-term support release. And this is actually what you should be using if you are going to production. They don't recommend using the latest version of Node.js. And then about every 6 months or whatever, they'll graduate to a new version of the LTS. So Node 16 will eventually, at the end of this year, will become the LTS version of Node.js. And that's first one to talk about is basically Node 16 is basically going to be a R&D version for at least the next 6 months. So this is the timeline, the way the releases work. So right now, they have a master branch, but then they, which is always considered unstable. But right now, Node 16, that's the current branch, or the active branch. Yeah, but the LTS version is Node 14. So in October this year, Node 14 will go into maintenance, and then Node 16 will then become the active branch. Right now, it's the current release, but eventually it will become the LTS version in October. So let's talk a little bit about the Node 16 features. So this one, if you have one of the newer Macs that uses the M1 processor, they've added support now into the binary. So if you're actually going to, if you want to be able to run with the latest version of Node, you can do that. Previously, you actually had to use either you compile from source or use a tool like the Node version manager or whatever to use the native version for the ARM processors. There's a new and updated version of the V8 JavaScript engine. And there's also new regular expression functions that are part of that. They also added a stable timers promises API. And they've also added the web crypto API. There are also some new Node API C methods. They've added support for the AbortController. Actually, that came in Node 15. They also added support for A2B and B2A. And they've also added support for source maps as well. So let's kind of go over the Apple Silicon stuff. There's a build group within the Node Foundation. That's all they do is provide support for all the different processors and servers and stuff like that that Node runs on. And they have this package installer, which installs a universal binary. So if you go to install this universal binary, it actually will run on either Intel-based chips or the M1-based chips. And then if you're actually going to install, let's say the NVS version or the NVM version, it's actually going to install just for that specific processor. Previously, like the older version, so if you actually go and take the package installer for like Node 14, it actually will run on these new Macs, but it runs under something called Rosetta. And Rosetta is basically, it's a translation runtime that Apple provides. So if you're running older Intel-based software and you want to run it on these new M1 Macs, you can still do that. So let's talk a little bit about the V8 9.0. This is the version that's in Node 16. And it has some new regex functions around the ability to return indices. And there's a /d command, or what you call it in regular expressions, but you can use /d in there and actually will return indices with your regular expressions. Also includes faster JavaScript to WASM calls. And so that's basically how they're doing the translation. If you need to execute basically WASM, which is it's like the runtime, if you need to compile code that is essentially, think of WASM as basically being like a runtime, or a JIT for like Java, but this is specifically for the JavaScript engine. And the idea here is that you can take, let's say, C++, Rust code, and then compile it into a runtime that will then run inside the JavaScript engine, but very, very quickly. And so they've improved the speed for the JavaScript to WASM calls in there. If you want to use that, you have to use this turbo inline JS WASM calls flag if you want to start using that feature. So one of the new features they have in here is the stable timer promises. And the whole idea with this is that you can import in these timers. And what they'll actually do is they'll allow you to put weights into your asynchronous code. So if you look at this example right here, we have a async function called do something. And then right here, we're console logging, but then we're doing an await set timeout 2000. And what this will do is it will, if you go to run this function, it's going to do something started or write that out with the console log, wait 2 seconds, and then run this delayed timers. So if you ever needed to be able to do a wait inside of JavaScript, this is the way that you can do it now. The Web Crypto API. So this is a newer version of the Crypto API. And the thing that's important to remember about this is that there's actually already previous versions of Crypto. And there's versions of Crypto that run in the browser and that run on Node.js. And so one of the things they've been trying to do is they've been trying to actually come out with a consolidated, universal version of the crypto libraries. And so if you need to be able to access this new kind of universal version of the crypto libraries, they actually have a subtle interface that you can use to get access to that. And so they're standardizing on a single standard. That's the key thing to remember here. And this is an example of how you use this crypto API. So if you look at this example right here, we're taking the crypto library and then we're importing in web crypto. And then from web crypto, here we're using a destructor to actually just pull back that subtotal property off the web crypto. And then inside of here, we're actually doing a shy HMAC and doing a sign and verify on this. And then this will create a hash that we can then use here and print that out. So this is an example. The nice thing about this is that you can write code like this and it'll run in the updated version of the browsers, and it also will run in Node.js now as well. So the NAPI is now being called the Node API. And this is essentially if you need to be able to write native modules and extend Node.js with C and C++ code, this is how you do it. And these are the new interfaces that were added for Node.js 16. You can see it's mostly around objects, and object freezing and sealing, that sort of thing. And that brings us to the AbortController. So the AbortController is another API like the Web Crypto API that has been available in the browsers. And they're actually, it became part of Node 15. So this is not brand new, but it's still, it's a neat feature. And so one of the things you can do with this is if you look at this example right here, we have this AbortController, and then we have assigned this add event listener to listen for abort on the signal. And then right here, we can call abort on the AbortController, and this will signal an abort through that event listener. And the key thing here is if you're using certain libraries, for instance, like Axios, or another example would be like the Fetch API, and you want to be able to cancel a request that's a long-running request, you can do that using the AbortController. A2B and B2A have been added as well. And this was done specifically for Node.js compatibility with the browsers. And this is used for converting essentially, strings and objects, this sort of thing, into base 64 and back. And I think this is the first time I put this in one of my slides. Do not use these new functions. And this is the same thing I believe that the Node Foundation is also suggesting. The only reason why they added these in here was specifically for compatibility. They wanted to make sure that JavaScript code that used this in the browser could also use this in Node.js. If you're going to be doing this, there's actually a better way of doing it. So I want to put this example in here. This is basically just using the buffer API. And you can see just by using the buffer API, you can specify like a string here, and then you can create a string buffer from that. And then from that string buffer, you can actually create a base 64 buffer. And then you can convert it back into a string, and then convert it back into something that's been decoded that we can then use again. So this is the way that you definitely want to go back and forth. If you're going to be taking something, converting into base 64, or taking base 64 and converting it back into something that JavaScript can understand, you should use the buffers to do that. Now that's a suggestion from the foundation as well. So some of the other features that are going to be in Node 16 is NPM version 7. They've added source maps version 3. And the process step binding has been deprecated. And that brings us to the last part. And that's what I'm calling modern JavaScript. So I just want to preface this by saying that a lot of this is my opinion, but there's some things in here. I go through, I see JavaScript code in my daily job. And there's a lot of stuff that I see where they're not using some of the newer versions of the syntax. And so while these features and stuff that have been added just recently, like in Node 16 and Node 14 are great, there's things that have been added probably 5 years ago that we could be using and using inside of our applications. So kind of start this, if we go back and look at JavaScript, the language has actually changed quite a bit. It was first introduced in 1995. And they very quickly changed the name to ECMAScript. That's actually the official name of JavaScript is ECMAScript. And they added version 2, which basically just kind of like standardized some things, but then version 3 added regular expressions. There was a version 4 planned, and it was basically basically JavaScript with types. And if you actually look at what Microsoft has since done with TypeScript, it was doing a lot of this. ActionScript was basically doing a lot of the same stuff. So version 4 actually was scrapped and became ActionScript and got used in the Macromedia / Adobe world for a while. And then V5 was added around 2009, added the JSON libraries, array functions, strict mode, and getters and setters. And so those are really kind of like the last or only really major changes that kind of came to JavaScript for a long time. So like for 15 years, there wasn't a lot of stuff that was really added into JavaScript. And then the version 6 specifications started to get standardized, and most of the features that were going to be in version 6 actually got divided up into what they called ES 2015 and ES 2016. And the key thing to remember about this is that what they're doing now with JavaScript is every year they're releasing new features. And so there's been ES 2017, ES 2018, ES 2020. So every year we're getting new features rolled out into the language that we can start taking advantage of. And the good thing now is that it's not like everybody's stuck in IE6 where it's like, oh, well, we can't use these new features. Yes, you can use these new features. And even if the browser that somebody's using is older, with transpilation, you can actually start using these features. You can target like a certain version back of the browser, but if people are using like Chrome as an example, or even Safari every year gets updated. So we start seeing a lot of these features pretty soon. So these are some of the features that have come since 2015. We got the let and const keywords for declaring variables. We also have for of loops now, arrow functions, promises, as well as async and await. The import export syntax, which really wasn't fully supported until about a year ago. And I'm going to get into that quite a bit a little bit later. The spread operator, destructuring, default parameters, the new target, no coalescing, and optional chaining. So these are all a bunch of changes and stuff that I think help us make it makes us a lot more productive that not everybody's really taking advantage of yet. So this is kind of a quick example I wanted to show of basically just declaring a variable in Node.js or just JavaScript in general. So if you look at this top example right here, we can see we have a variable called num, and we're setting that to 5. And we can print that out. That works just fine. And then we can actually declare it below. And so what this is actually doing, this is hoisting this to the top of our context. So this code will work just fine. But if we go down here to this bottom example here, you can see we've done something similar with that variable. And then we're using the let keyword. And the let keyword doesn't allow you to hoist to the top of your context. You'll get an error if you try to run this code. I actually think this is cleaner. It's cleaner to use the let than to use the var. So this is an example, like whenever I go through code and I see var used quite a bit, I look at possibly using either let or const. And this is another example of hoisting. So if we look at this example right here, we have the var keyword here, and inside of this host name or hoist name function here, we have a variable that's been declared, and we're doing the same thing here with the var. And this will work. And I can come down here, I can run that function, and it'll return the name. But if we look right here under other cat's name, we'll get a reference error to that because that's not visible outside of the scope of the function. So that's just one of those things to kind of be aware of, is make sure you understand how hoisting works and where you should be using let and const. So as we said before, var will host to the top of the scope. Let and const will not let you hoist. Const is supposed to be write once, read only, but in reality, it is possible to make changes to objects and stuff that have been declared with a const. So it brings us to object construction. And so the traditional way you create objects inside of JavaScript is using function prototypes. And one of the things that was added just within the last 5 years has been the use of the class keyword. And class is kind of controversial, because if you think about JavaScript and compare it to other languages, let's say like C# or Swift or Java for that matter, those languages are actually object-oriented programming languages. And you can do object-oriented like things inside of JavaScript, but JavaScript is really what's considered a prototype object-based language. And it's modeled after functional programming languages. And so one of the things I know I try to do is I try to use JavaScript in a functional way. There's a lot of people that are fine with the class keyword, using it the way it is, but it doesn't behave the same way that the class keyword does if you're using a language like C# or Java. So, and we also have the ability of creating objects using factory functions. I'm going to show an example of that as well. You can also use object literals. And there's the object.create, object.assign, object.freeze. There's a couple other functions you can call off the object to actually create new objects. So this is an example of how you'd use function prototypes to actually create an object. So if we look at this example right here, you can see I have a function that I've declared called thing. And then it's basically operating as like a constructor for this object. And then it returns this. And then one of the things I'm doing here is I'm actually going to the prototype of thing, and I'm creating a new function called getName that returns the name. And then below that, I'm actually declaring a new thing called my thing here. And then if I go to get the name of that, it will return the name of this prototype. So you can do the same thing using the class syntax. And I think this actually does look a little bit cleaner than the previous example. This actually has a constructor method that you can use, or function. And you can do the same thing with the getName. It's all part of the same class structure here. And this is me instantiating that and getting the same thing as before. But one of the things that Douglas Crockford is kind of a fan of is actually using factory functions. And so if we look at this example right here, I have a function called createThing. And it's also got a function there for returning the name. And then it returns a new object with the name and this getName function inside of an object.freeze. And what the object.freeze does is it actually makes it so that this object, once we create this object, it can't really be modified once we've created it. And the thing that I like about this approach is that we don't have to use the new keyword. And another thing we don't have to use is the this keyword. And so one of the things that can be kind of confusing about JavaScript is that you have to be careful how you use this. One of the things you'll see a lot of, and especially some older JavaScript codes, you'll see a lot of places where they'll say that is equal to this, and this is equal to that, and that sort of thing, kind of littered throughout the code. And that's because they're trying to maintain the original scope inside of another scope. And so one of the things I like about this is that we don't have to use this keyword, and we don't have to use the new keyword either. This just creates a brand new object based off of the function. So this is some other magic here. I kind of like this because I like, if you're thinking about using inheritance, what's nice about this approach right here, so if you're using object.assign, you can take an existing object and then you can add the properties and the functions of another object to that object. And if you're actually using the spread operator right here in this example, this is fairly new syntax. What this will do is this will clone a copy of that object. And then we can see right here where they've actually taken this one object and then they are using the spread operator on this other object. And what this will do is this will combine a brand new object with the contents of both. And so I think this is a nice approach as well if you need to be able to create a new object. The for of syntax. And so one thing I want to do here, I have a post I did called 8.5 ways of being able to iterate through arrays in JavaScript. And what I thought was interesting about this is if we look at these two different ways here, they've had the for-in syntax in JavaScript for a while, but what for-in actually does is it does not return an actual item inside the array. It actually returns the index inside of that array. And so you have to use the index to reference the specific position in the array if you want to be able to access that value. And so if you use for of, what it's actually going to do here is it's actually going to return the item. It's also a little bit safer of a language construct, because if somebody goes in and they add a property to or a key to an array, that will also get included if you're using the for-in. And if you don't want to use outside properties and stuff inside of your actual array, this actually, I think, makes it a little bit safer. So I try to use the for of over the for-in if I'm using that type of loop construct. Arrow functions. So this is another cool feature that's been in the language for about 5 years or so. And if we look at this example right here, we can see here that I'm printing out 1, 2, and 3 here. And if we look above, we can see that I have this prn2, which is an arrow function, and it's just basically taking whatever I'm passing into it and printing it out. And then this prn3 essentially is doing the same thing as well. The difference is that it's a little bit more formal of a structure here. And so these functions are essentially the same. And then down below here, I've actually have a function called prn1. Now, one of the things you'll notice here is that this code will run. If I tried to take these two arrow functions that I defined up here and move them below these statements, that actually would generate an error. But the original functionality inside of JavaScript is that if you write a function, it can be used. You can write that function below where you're actually calling it, and it'll still work. And so this is an example of hoisting, where hoisting actually is doing what we want it to do. So you do have that option as well. But I'm seeing increasingly more and more code where people are using arrow functions, which is good. So one of the things I also want to talk about is promises and async and await. So one of the things that's pretty common with a lot of the early Node code that I wrote is that there's a lot of these what I call error first callback functions. And essentially it's a function where you pass something in and then you also pass in a callback, and that callback, it expects it usually expects an error and then the results as the second parameter in that callback function. And promises have really, I think, kind of helped simplify how we make calls to asynchronous code. And one of the things that's really nice about async and await is async and await have even made things even more simpler. So when you create a function and use the sync at the beginning of that function, essentially what you're doing is you're making a promise. And you can put the waits before any promise where you're waiting for the results to come back. It essentially works the same way as if you're calling then on the promise. So this is an example here of error first callback. So you can see here we're calling up the file system module, and then inside of there we're passing in a path, and then we're passing in this function here that has the error first and then the result second. And I used to write a lot of Node code this way. And one of the things that I think a lot of people were kind of disappointed with Node when they first started looking at it is if you have callbacks inside of callbacks, you can wind up with these like tree-like structures of, one callback that then has to call another callback that has another callback to handle all the asynchronous nature of JavaScript. And so there is a better way. And so one of the things we can do is, like, if you still have code that uses error first callbacks, there's actually an API that's been available for a while called util.promisefy that will let you take an error first callback function and convert it into a promise. And so if we look at this example right here, I'm taking that same FS read directory and I'm calling promisefy on that. And what that actually does is that takes that function and turns it into a promise that we can then use. And if we take a look at this example right here, we can also use this with the sync and await syntax. So here, I've called this the promise. I don't have to use .then. I can just say await FSP and pass in the path. And then whenever it's done, getting back the synchronous value, it's going to assign it to this variable. So it lets you write things in a synchronous way, which is quite nice. Fortunately for us, we don't actually have to use util.promisefy on the fs.read directory because there's already a set of promises that have been added to that module. And so you can just import those directly off of the fs/promises. And there's most of the APIs now that are in Node.js that have to be able to handle something asynchronously. There's been promise-based libraries that have been written for those. So in this example here, we're getting back a list of files, and we're just saying, hey, we'll just await for whenever it's done, and it works the same way. So here's an example of using Node Fetch, and you can see right here, Fetch is kind of famous for, if you're trying to get back the JSON as an object and stuff like that, you actually have to call wait twice. So if we look at this example right here, I'm calling this get some data, and inside of here, I'm waiting to get the result back where I get the full response, and then I have to get the JSON off of that, which is a second await call. And so one of the things I like doing when I'm having to make REST-based calls from Node.js is I prefer to use the Axios library. And one of the things that's nice about this library is you only have to call await once. And as a matter of fact, I could have made this one line shorter. And another thing that's nice about this, I'm using the import-export syntax here. As you can see here, that there's no built-in library specifically for handling the module syntax inside of Node Fetch. And so what I'm having to do here is I'm actually having to do an asterisk as package here to get all of the functions that are inside of Node Fetch. And then there's one in there called default, which actually has the promise. And then I'm just basically setting this variable to that. And so I like the Axios library a little bit better, but they both essentially do the same thing. And that kind of brings us to talk a little bit more about the import-export syntax. And so this has actually been a little bit kind of controversial because of the way that require worked, where you could pass in modules. It basically was set up so that you could use different paths in different ways, and you didn't have to include the JS extension. And there's all kinds of inconsistencies in the way that require worked that made it very difficult to actually import and export or using the new import-export syntax. And so essentially what the import and export syntax do is they replace the need to use require or the exports object. And so the way you can do this, the way you did this previously is they had a .mjs, .cjs extensions. So the common JS, the older require type syntax would go into the .cjs extensions, and then the new module syntax would go into the .mjs. And nobody liked this. Everybody hated this. And so one of the things that they changed in Node 14 was that you could default to one over the other when you're writing a new module. So you don't have to specify a special extension here. So the way you do that is in your package.json. What you can do is you can specify a type. And then a type, you either specify CommonJS or module. And so if you use module, you can use the new import-export syntax. If you're using CommonJS, then you'd use require. And so one of the things I've started doing recently is I've started actually using, I'm just defaulting type to module. And so when I'm writing my code now, I know as long as I'm targeting Node 14 or later, I can just basically specify module as the type, and I can use the import-export syntax. And it's actually still possible to use the require and import inside the same file. And so here's an example here of me using the require to get that redirectory. And if I switch the type over to module, all I have to do now is this. To get that redirectory, I can just do that. We've an import from, and then I put the redirectory inside of a destructor. Now, if I want to be able to use create require, and there's going to be like, for instance, if you're using native modules, not modules that were written with C++ as an example, and you still want to be able to use the require syntax while you're using the import syntax, the way you would do that is you do a import create require from module. And then what you can do is you can actually create that require function using this create require, and then you just pass in the import.meta.url so it knows which folder to start from. And so there's a technical analysis library that I've used in the past, that's one that's written in C++. And so to be able to use that, you have to be able to use the require syntax, but I didn't want to give up having to use my module syntax. And so by doing this, I can actually use the import syntax and use require all inside the same file. So this is how you can do that. And then if you need to export using the import-export syntax, this is an example of, I don't know if anybody here is fans of the Star Wars, but this is an example here of where I'm actually calling the Star Wars API. I have 3 functions that I've created. They're all asynchronous functions, and they all return back the results for vehicles, planets, and starships. And then I can export this all out using this destructor. So here I'm just basically specifying I want to export out to get vehicles, get planets, get starships into this module. So that brings us to the spread operator. So the spread's really nice if you need to be able to take an array or concatenate, one array inside of another array. You can do that very easily with the spread operator. But something that's also very important to remember about the spread operator is that when you're using the spread operator, it's actually going to clone a copy of the array in this case. And so that's very handy. If you need to be able to clone something, make a copy of it, use the spread operator to do that as well. Something else that's also nice here is we can use this destructor syntax here. So if I need to get the first, second, and third positions of this array, all I have to do is put that inside of square brackets, and then the 0, 1, and 2 positions of that array will be assigned to these variables right here. And also very similar here with this object down below here, I can destruct these different keys into their own variables here that we can then use down below. So that's an example of the spread, but it's also an example of the destructor syntax. And let's talk about default parameters. And so I remember about 10 years ago, I was at a presentation showing off some new features of C#, and C# added default parameters. And I remember looking at that, and I'm like, and they're showing how you could set up a default parameter where you don't have to use that parameter. And I was like, well, you could also do that with method overloading. And And so I was kind of taken aback by that, but it actually does give a very quick, now instead of having to write two functions to essentially do this, I can just write one function and then assign a default to the other one. So you can save time by using this. So if we look at this example right here, I'm using the set timeout. And for the first one, it's just going to default to 3000. And for the second one, I'm setting it just 1 second. So look at this. The first one would get printed out, and then the second one will get printed out 2 seconds later. And that's because I'm able to, it just assumes this first one that the default is going to be 3 seconds. Do.target. I don't know how, I haven't seen this used quite a bit, but this is actually kind of a handy, it's kind of a handy feature. So if you're using something like function prototypes as an example, you want to make sure that anytime that somebody's going to instantiate this, they're using the new keyword. You can actually force that by using this new.target. So if we look at this example right here, this is using new foo, which is actually going to create a new version of the object. And then here you can see that it actually logs this out. But if I just try to call this without using the new keyword, it's going to throw an error. So if you need to be able to enforce that type of functionality inside of your JavaScript, you can do that pretty easily using the new.target. And that brings us to nullish coalescing. So this is another feature that I started seeing a couple of years ago in some other languages. I think Kotlin and Swift both use this. Maybe it's Kotlin that uses this. But the idea here is that when you're trying to get a value back from a variable or from a value, and let's say in this case here, it's undefined or it's null, you can put this nullish coalescer, which is basically just two Elvis operators or question marks right next to each other. And so if you're getting a value that essentially is going to be null or undefined or nil or whatever, you can specify essentially a secondary value just in case the first one didn't work. And so this is very good for error handling as well. And then you can also see here, they're using this in the case of a false. Since this is actually a valid value, it's actually going to return false. And NaN, that's actually a legitimate value. So this would return NaN. And this one is another feature. This is a feature I've been using in Swift since it came out. And this essentially is the optional syntax. So whenever you see the question mark followed by a period here, essentially what this is doing a test on the object here. So if I'm trying to, let's say, get the zip code off of this person object, and we know the zip code is going to be inside the address, I can do question mark period address, question mark period zip code. And that way, if there isn't a value in here, I've done a test to see whether or not the value's there. And if it's not there, then it'll just assign an empty value to the zip code. So this is pretty handy. I think we're going to start seeing this a lot more inside of JavaScript. And that pretty much concludes all the new JavaScript language features. And I wanted just to take a brief moment to talk a little bit about TypeScript. And so I've been kind of following TypeScript from afar. I don't really use it in my day job, but I'm a big fan of Anders Hellsberg. And so if you're not familiar with Anders Hellsberg, he's the guy that created Turbo Pascal. He also invented C# at Microsoft, and now he's working at TypeScript at Microsoft. So he's a great language designer. And TypeScript essentially is just a superset of JavaScript. And what they essentially did is they did what ActionScript was trying to do in version 4. They've added a type system to JavaScript. And it does require a transpiler, or if you're using Deno, Deno will handle TypeScript by default. But the key thing here is that it allows you to create defined data types that can then be used inside of JavaScript. And the purpose for this, they said, was for large projects. But one of the things that's really nice about TypeScript is if you're using it in conjunction with a tool, let's say like Visual Studio or Visual Studio Code, you can assign these .d.ts files, even if you're not using TypeScript. And what it'll do is it actually will give you, if you're, let's say you're using a library, let's say like Lodash as an example. Lodash, I don't think has a TypeScript equivalent, but if you use these user-defined, basically definition files for TypeScript, it actually will give you code completion as you're typing out inside of your IDE. So it's a very, very handy thing. If you're using, even if you're not using TypeScript, you can use these code completion type features and stuff by leveraging the definition files. One of the things that I thought was really interesting about TypeScript was that I used to use Angular about 5 years ago, quite a bit. And that was right about the time that Angular 2 came out. And one of the things the Angular team at Google did was they adopted TypeScript. And so now when you're doing Angular projects, you use TypeScript to do that. They actually write Angular using TypeScript. So if you're going to be using Angular, for example, they do use TypeScript. And there's a number of different projects and stuff that you can start off with. Even React now, you can use TypeScript with React. And so there's some really nice features and stuff. And my suggestion, if you're actually going to be using the class keyword, you might as well be doing it with TypeScript, because they do take all the typing and stuff into consideration. So I have a bunch of blog posts I've made kind of related to some of the subjects and stuff that we're talking about tonight. I'm including that in the slides. I'll also put it up on the meetup as well if you want to read through these posts. That is pretty much it. Does anybody have any questions for me? No questions? All right, well, I'm gonna just finish up by saying, we talked a little bit at the beginning, but a bunch of people joined after we started. So previously, up until last year, we were meeting at Availity, and the plan is, I think, to continue the meeting at Availity for our user group meetings. One of the things the users have requested is that we continue to do the Zoom meetings. And this summer, the plan is we're actually going to start meeting at Spinspire this summer. And then once Availity opens back up in the fall, we'll start meeting at Availity again. But we're going to continue to do the Zoom meetings. So for people that maybe they haven't had a vaccination yet and they're worried about going out in public, or it's just more convenient for them to be able to meet on Zoom, we're going to continue doing the Zoom meetings like we have been doing. But we're also going to be doing in-person meetings as well. So that was kind of like the last announcement that I wanted to make with that. So with that, one last chance if anybody has any questions.
Hey, David.
Yes.
Sorry, my daughter's asleep on me.
No problem.
I have a quick question. Would you, the optional operator with a question mark,
yes,
with regard to validation, would you consider that in lieu of validation, like an if? Like I'm pretty green, but I'm just kind of curious, since that's brand new, is that meant to replace the validation function?
It's basically it's meant to kind of prevent an exception. So like, for instance, if you're trying to go through and get a value off of properties inside of an object, if that property doesn't exist, it'll just crash your application. Or
like a null, right?
Yeah.
You're preventing nulls.
Exactly, yes. And so what that does is that helps eliminate that whole type of error. It doesn't mean you still need to have validation, because for instance, if somebody, if a zip code is required and they haven't passed in a zip code, you still need to check to see whether or not they have a valid zip code.
Okay.
So yeah, it's basically, it's meant it's meant to be a prevent from preventing having those types of errors. It's interesting. I've been using Swift now for about 4 years, and this is, that whole optional checking thing is a critical piece to Swift, because by default, any variable or object that you create inside of Swift, they want it to be immutable. And they also want to make sure that, you're not passing in null or nil values inside of your objects. And so Anders Helsberg, who I mentioned before about TypeScript, one of the things that they considered when they were designing C# was not having null at all inside of the language. And the reason why they did that is because if you look at languages like Java and other languages, for that matter, that allow nulls, about 50% of the errors that you get, or at least a lot of the errors that you get, are related to objects or properties that have not been instantiated. And it's very common to see that kind of error in your code. And so anything that the language designers can do to kind of like eliminate having those types of errors and stuff like that, not only makes our lives easier as developers, but also reduces the cost of software development. And so at Microsoft, they called that, I think, the $1 billion mistake. It's probably more like a $1 trillion mistake. But in a lot of functional programming languages, they do not allow null. So it's more of the general purpose languages where that's allowed. But there's been I remember going through logs and just saying, it's like, well, somebody didn't set this object. it's still null. So that's a very common thing.
Thank you very much. This is a great presentation.
Oh,
So
thank you.
A lot of stuff to munch on there.
Awesome. I'm glad you appreciate it. All right. Well, I'm gonna put these slides up on the Meetup site, and also we'll be putting this up on YouTube as well. So if you want to go back and rewatch it, you can do that as well. So thanks everybody for coming out. I'll talk to you later.